morning. I hope you all got some time to get a coffee break. A quick intro about me. I've been in cybersecurity for nearly 2 decades. Before the cybersecurity industry was such a large group of like over 2,000 companies right now. It was only, I would say, a dozen companies way back in the days. So I've seen the evolution of threats, products, and technologies in the past couple of decades, literally. So it's an honor to be here to launch the cybersecurity track here with you all. There's a lot of talk about cybersecurity in the industry today, So I'll kind of break it down a little bit on how we are seeing cybersecurity and AI and the combination of these, in a real world environment where you can productize and leverage artificial intelligence. So I'll talk about that and why do we really need it in cybersecurity particularly. Talk about some concepts there. The evolution of AI in cybersecurity, what we see is working, what is not working. So we'll talk about that. And at the same time, how can AI be abused from an adversarial perspective? So we are seeing AI also being used by attackers. So I'll go over that as well to give you a perspective. And then hopefully we'll have a kind of conclusion and I'll open up. I'll try to wrap up in around 30, 25 minutes. Can you get the timer here started? Thanks. All right. So about Cylance, as Raman just said, we have kind of been fortunate to be the #1 endpoint security company, which is completely based on AI. It was a crazy thought way back in 2012 when the company was founded by the global CTO of McAfee, Stuart McClure, and the chief scientist, Ryan Perma. And amazing traction in the industry, one of the fastest growing cybersecurity companies ever in the shortest time. Huge global presence now. We are doing a major global expansion right now. Over 6,000 global customers and over 16 million endpoints in the span of just barely 4 years, which is probably one of the fastest ramp up in the endpoint security world, which also shows that AI can scale very well and very fast. It's kind of a proof point of that. So with that, I know a lot of people ask me, why AI? Why do you really need AI? And my simple answer for that is, artificial intelligence is better than natural stupidity. And what I mean by that is, we are humans, we make mistakes. Machines, if trained well, can do things better than us in some aspects. It's not everything. So there are some various areas or various avenues where you can actually learn and adapt and get better instead of doing the same thing again and again and again and using humans there, right? And hopefully, as I go through the entire conversation, I will explain this in more details. So we use AI and ML together. Literally, it's kind of almost the same thing. And I would say there's a lot of confusion. People think that it's the same thing. I would say they are kind of very close in terms of technology. AI has a broader scope. It's more generalized. Machine learning is more designed for it's like a computational statistics oriented. It's designed for very specific topical problems like spam, understanding probability analysis and optimization. So AI has a broader scope, and we'll talk about that in details as well. But just wanted to kind of bring it out there that AI has a much broader and bigger scope than ML. So a brief history of AI and ML. So I think we are right now in a bit of a hype cycle, but this has happened in the past as well. Right in the 1950s, when the Turing test came out, people have been dreaming about smart machines. How can you make machines as smart as humans? And there was, in the 1960s and 70s, there was a big surge where people actually thought that AI will be a big theme. But you know what? It didn't come out. Around 1987, the Lisp language which came out didn't really function as much as it was anticipated to be. So it was that kind of led to the AI winter, where pretty much it became a term people wanted to avoid. So all throughout from 1985 till 2000, people were actually trying not to use the word AI, even in research documents and so on. There were concepts called cognitive sciences, cognitive analysis, and smart systems, and so on. People were trying to avoid the term AI because there was a big negative thought process behind that whole terminology. And then around mid-2000s, AI came back. Why is that? First of all, I would say internet speed. The internet has created new challenges for us, and of a very different nature and scale. Second thing, I would say the compute capabilities, the elastic cloud, the GPUs which are now available, none of this was available. AI training is expensive. You need lots of data. You need a lot of computational power. So it's not easy to build out an AI product or a technology without all of these computing resources, which wasn't available earlier. So all of this kind of created a perfect storm to kind of lead into this new wave of AI, and we are seeing the implications of that in pretty much every industry right now. And not to forget, we definitely have also evolved in the algorithms. You must have all heard about deep learning and some of the advances in AI technology as well, which kind of made this a far more viable technology than what it was in the 1980s. So now I think AI is there pretty much in virtually every industry, from autonomous vehicles, I think you must have heard some in the keynote, to healthcare, to cybersecurity, to space exploration. So we are seeing the implications of AI as a technology stack across several verticals. So let's talk about cybersecurity in special. Why is AI needed in cybersecurity? And I call it, being in the industry from the very beginning, I always say that we are at a negative 100% unemployment rate in cybersecurity. For literally every 2 job openings are there for a well-qualified candidate. It is good talent is almost non-existent. It's very hard to get good talent, right? And we are really starving for talent right now in the cybersecurity industry. And that's also because cybersecurity is now impacting across the board. It's not just about network security and endpoint security. It's a wide, very fragmented, broad base of areas where cybersecurity has become a concern, ranging from IoT devices to the cloud and whatnot. So that scale, you just don't have enough people. So you have to get smarter about dealing with the cybersecurity challenges. So using something like AI actually gives you a new level entrant to do bigger things with less using technology. And at the same time, for veterans, instead of doing the mundane tasks, you can actually amplify your existing skill set and do smarter things and faster. So it's a very, very good fit, and I would say perfect timing for InfoSec that AI wave is actually being launched out here. So, and I think the other advantage is AI never sleeps. Cybersecurity is not a thing you do 9 to 5. It is about being there always, all the time, 24/7. So there are obvious, having machines take over key cybersecurity challenges is going to be I would say, very beneficial for all of us. So how is it all done? What is working? How are products being built in the area of cybersecurity? Since I'm sitting with a lot of entrepreneurs and people who are building products and companies, so I thought I'll give you an insight of what we have tried, the formula which has worked very well for us. The first of all is Observe, which is the data collection. As I mentioned earlier, data collection is key, right? So now we are in a completely different world where everybody wants to be the source of data collection. And so you need to have access to data. If you're building a cybersecurity technology or a company or a feature, you have to be sure that you have access to lots and lots of data, right? And sometimes petabytes of data. It's a new norm now. And then you should be able to get a data set regularly, consistently, all the time. It's not a one-time thing. Data also ages, right? And threats also change. Then once you collect the data, you have to orient the data to add context of what this what this really means from your perspective. And the good thing about training machines is that machines don't have an inherent bias. Machines, unlike humans, you tell them this is what this means, it will work exactly as per spec, right? And modern algorithms can actually help to add context and really identify patterns to make this data well curated, which can be used for training sets, right? So this is the second important aspect. Then is the decision piece, wherein how can you make decisions? And AI can actually enable that, wherein you can literally choose millions of options and make decisions out of them. You can be selective about that. This is where the AI gets interesting. Then after that is the action piece, where you actually act, whereas you actually make decisions in sub-milliseconds. This is I would say, the most key piece, where you're able to now collect, curate, decide, and then act on this. And then the next piece, which is also very important, is repeat this. And it's not just blind repeat, it's actually repeat with feedback. So wherein you know what is working, where are the false positives, what are the false negatives. So you kind of build a loop which is getting better and better and better in a cycle. That's how you build out a kind of a end-to-end product, and this is what we call as training models in the AI world. So I would say AI in cybersecurity is very new. It's a very young industry leveraging AI. I would say most technologies that you will see are, I would say, in the first or second generation. That's the complexity of how well you can curate and extract features. I'll talk about feature extraction and clustering in a bit, but it is important to understand that AI can also be bypassed. It is not a silver bullet. It is not something which is going to solve all your problems. I see this as a very good replacement of the legacy way of doing things, which is deciding on what is known good and known bad. You learn all about that, and then you expand on top of that, and iterate, basically. So it's an automation play more than anything else at this point, and there's a long way to go. We have miles to go before we can actually build a real, robust, mature AI system. So in InfoSec, some of the areas where we have seen AI being used, it's actually in various places, from network traffic. You're looking at sensors which are identifying anomalous traffic. It's heavily used there. There are several category of companies doing that. User behavior analytics, like for example, identifying the users based on you read a user's profile, build a digital fingerprint, and once they deviate from that, you can actually identify what is good, what is bad. So it's actually being used for a category called UBA, user behavior analytics. NLP, signal processing, looking at signals. This has been there for many years, used by the governments and army as well. Log enrichment, SOC automation. So one of the challenges enterprises face is SOC. They have built SOC teams. Now they have tons of tools. How can you automate the various tools that you have built out? So you can do things intelligently. SIM workflows, forensics, and obviously malware prevention. So these are some of the areas where you will see a lot of AI being prevalent. And of course, not to forget the good old spam. Spam filtering is heavily dependent on AI. In fact, spam engines have been using Bayesian filtering and ML-based algorithms for decades now. So a little bit about how this works in the context of cybersecurity, how you would use an AI algorithm, how would you build a model, right? So imagine that you have two traits of a binary file. One is a sequence of instructions and the file size, just 2 dimensions, right? So with that, what you take is you take 1 billion pieces of malware, or a small sample set to kind of decide and train on extracting features from both of these 2 pre-labeled file set. One is good and one is bad. And then how AI works is once you learn and you extract these features, you basically create a boundary called the decision boundary, which basically you know that if it crosses this threshold of scoring, this file is good or bad, and you're able to learn that proactively, right? So learning is basically automatic, and then you find the decision boundary and you can decide whether this is good or bad. This is kind of a classic way of supervised learning. This is the most, I would say, commonly used means of building out AI-based cybersecurity products today. And then the next one is unsupervised learning, which is where you have no labeled data. You just have this, you kind of cluster data based on what you see, and then you need an expert to classify and triage this data, saying that this is a good set, this is a bad set. Like, for example, this could be a ransomware cluster, this could be a Trojan stealing your banking password. These are all different clusters based on what we have learned. Somebody has to sit down and label that. So this is being used in various fields. I know that the ad industry is using this heavily. But from a cybersecurity perspective, it's very different because you have to understand good and bad. So you have to have training sets built accordingly. So that's the supervised and unsupervised learning. And now I just mentioned two traits here, which is the file size and sequences. Just imagine I add 100 different capabilities or files or traits of a file. So now this becomes a multi-dimensional array of records, which can give you a lot of rich data enrichment capabilities, which is why that's kind of how models are built behind the scenes. So in terms of trends, as I mentioned, AI is being used for both good and bad. I'll talk about some interesting trends that we are watching used by the good actors as well as the bad actors. So the good first, the good news first. So one is what we see is that we see a lot of dozens of companies trying to build AI by classification, very similar to what I just mentioned. You train, you collect a lot of data, files. It could be structured or unstructured data, depending upon what you're trying to solve. And then you classify, you transform, and then you start build monitoring systems. It can be used for prevention, if you have a very mature AI-based technology where you can actually block stuff. But most of the stuff is being used for monitoring right now. Next is reverse engineering. So when we build out really advanced, when you're talking about nation-state attacks, these attacks, you need really sophisticated analysis capabilities. So in this, what you do is you decompile a piece of malware, and then you identify, okay, these code constructs look like evasion, they look like mutation. And then based on the code, you learn and adapt, and the next time you come across similar code patterns, you identify that this is an advanced attack vector. So this is also being developed in research phase, but we see I'm kind of expecting the adoption of this fairly soon in the industry as well. This is the cutting edge AI for cybersecurity right now. Then attacks on AI. This is, again, a very fascinating area where bad actors are using artificial intelligence for launching attacks. So first of all, you have to understand the limitations of AI. AI is as good as your data set. I don't know if you've heard about this, where Google's AI thought a turtle was a gun, right? I don't know if you've heard about that. So if you classify or build a data set which is not high quality, you will end up with bad results. That is bound to happen. So it's still a very human-driven, I would say, technology at this point, at this phase in cybersecurity. So attacks against AI systems. How would I launch an attack against an AI system? So for that, first of all, if I recover the model, I can reverse engineer the model, and I can say that this is how the model was built, and identify the weaknesses in the model. Then the most common, the easiest way to do that would be just feed bad data. Because I'm depending completely on data to build models, all I have to do is feed bogus data or feed bad data and confuse the entire model. So this is, and we are already seeing some of that come up. It's at a very small scale, only used by some attack adversaries, but not very common. But we are seeing that as a trend, this could become a big problem in the near future. And then, and then if you can identify the model, you just have to alter the model. You just play the model. You need to identify what are the weaknesses, how is this model scoring, what are the traits which I can change or tweak in a malware to basically completely confuse the model. So these are some attacks against AI systems which are in place in early stages of research. And then if nothing works, use the good old denial of service, DDoS, the entire machine. Just confuse the whole system, right? So bad AI. So this is something which I think if you have a Twitter account, you probably might have seen some of this already. This is how I would do build a bad AI system. Would be, you have Twitter users. I troll every user on Twitter, and I learn what you like, what you don't like. If you like to buy shoes, I know that's your vulnerability, right? If you like to read books, I know that this is what you like. So I profile you. I build what I call as feature set of a user per user, and then I build clusters on how many people like shoes, how many people like to go to Facebook, how many people like XYZ, based on the interests. You cluster all of this. And then you identify the targets, and you sell this in the underground, saying, I have this shoe store. I want people to. I have classified people who like shoes of this type. I will sell you ads, or I can send you spam based on very targeted Twitter campaign which I just ran, right? Then what you do is that you just do a random text generator, write a bot with this data, and then you just feed it to Twitter, and you can do a mass spam campaign on Twitter. Some of this is already done. This was actually demonstrated at Black Hat a couple of years back, but I totally expect that this is already happening in the wild as of today. So this is you're using automation and AI for actually doing mass spam campaigns, basically. And the same concept can be used for email as well. Based on what you click and you like, people know the success rate, and this is what they will target. And this is I would say, the most easy and the most commonly seen attack using AI right now. So the other piece I kind of keep on hearing about AI is the fear factor. I would say it's primarily fueled by Hollywood and the books you read, a little bit of the Elon Musk effect also, I would say, to some extent, where you feel that the demons are going to come and it's going to be the end of the world. And job displacement, people are actually worried about the fact that AI can take over jobs. People are genuinely scared. I remember when I used to pitch our technology, people were like, my job, I'll lose my job. I mean, so I think we are probably far away from that. From those Hollywood scenarios, at least in the area of cybersecurity, I can say for sure that it's still early days. AI will actually help you get better. It's a tool. It's not against you. It's for you. And then, of course, AI can also be used in warfare. When you talk about cybersecurity, you also have to consider all of that as well. Drones and actually launching attacks, leveraging AI based on what you see and what you learn. So yeah, I'm sure a lot of this stuff is happening, behind the scenes as well, as we invest more and more in this area. But yeah, this is something which always keeps on coming up. There's always a fear factor for AI. Like when the cloud came out, people were not scared about the cloud. But I remember back in the days when Microsoft Word came out, people were worried about losing their jobs. People who were in the job of typists, they thought they will lose their jobs. But now they got Word, they actually have I would say better and better opportunities of doing more stuff with Word than what they could do with a typewriter, for example. Right? So I would say long ways to go to kind of cyber, where the bots take over. We have a lot of long way to go from here. In terms of conclusion, I would say automated attacks are on the rise. You need something reliable and consistent, which can actually scale. You need smarter responses. You don't have enough skilled manpower, so AI actually augments that. We have trust issues with AI simply because it's a brand new technology, brand new wave. So it will be a while where people actually start getting comfortable with it. You have to demonstrate that AI actually works and actually solves problems. It's not human versus AI. It is humans with AI is the way I like to define it. We are not fighting each other here. It's, again, machines which we are building. AI is impacting several industries in a big way, and we have just begun this journey in the InfoSec world. It's still early days. There's a lot more to be done. So with that, just finishing on time, I'll open up for questions with a slight note of humor where the quality of AI also will depend on how whom you're training on, right?
Okay, so there are my setup. Anyway, if you have any questions, please come our way, or if you feel like your voice is loud enough, stand where you are and shout.
Yeah.
Yeah, go ahead.
First slide, you talk about sensors, right? So what kind of sensors are out there, and what kind of data do you collect, especially in terms of predictive attacks?
It depends what you're trying to solve. Like, in the endpoint world, we need files. So, we are looking for files, where we can get good and bad files. If you're talking about building something for the cloud companies, you need user data. Like Facebook looks at user data and builds models on top. So does Google. So it depends on which area you're looking at. But ultimately, you need a data source, depending upon which problem you're trying to solve using AI. It's heavily reliant on that. So in the cybersecurity world, it's mostly logs of different products. It's network traffic data. It is files. It is error logs of failures of exploit attempts, for example. So it's basically whatever could give you a suspicion or a signal that something is bad is kind of commonly used as sensors. And you need lots of them. Just few would not help. You're talking about millions and millions of sensors because you are heavily reliant on quantity as well.
Hi, this is Venkat Rayapati. I'm from Cyberforce. Just to have a clarification about one of the questions is, today when you're using the AI, what is the effectiveness in terms of, today the cyber attacks are happening in various forms. For example, WannaCry, ransomware, which has been really spread widely in all the hospitals, different banking institutions. So how does your AI, in terms of what way it is able to prevent this? Because a lot of the stuff is really identifying or detecting and alerting. But prevention is the customers are looking forwards.
Yes.
So what can you do for that?
Yes. Good that you asked this question because that's kind of what we specialize in at Cylance, right? Yes, so the idea is exactly to ultimately prevent. And prevention actually is a sign of maturity in cybersecurity. That when you can prevent, that means that you have quality. You have confidence that you can actually block. Because the biggest challenge people face is false positives, and they cannot take action. They get a lot more noise, right? So it's about how robust and how well you can build a system. Like, for example, we had some very interesting, very good case studies out of ransomware attacks when WannaCry happened. All of these were just of a class called ransomware. And ransomware does something very similar, which is it ransoms and encrypts your file, and then it asks for ransom, right? So if you can learn what a ransomware looks like, you can actually very reliably build a technology which can actually prevent. And so far, we have seen close to 99.5, 99.7% effectiveness in preventing attacks of that type exactly. So it's very high. It's much better than the traditional way of doing signatures, for example. And we have enough proof points in the industry to demonstrate that.
Just to build on that question, how do you say the fileless attack more better?
Yeah, you can learn from based on behavior. So file is one form of attack. So ultimately, when you have to do contextual analysis. So you look at the behavior of what fileless attacks are scripts or in-memory payloads. So you know what is bad when something changes, and then at the moment something bad happens, you can actually block it at that time. So there'll be multi-contextual analysis, not a single file scan. That's a different technology base to block that.
You talked a little bit about endpoint security and how AI can help there. Can you also touch upon application security and how AI can help on that?
Sure. So application security is also at a big flux right now. So what you're seeing apps being, both internal and external facing, being developed by like hundreds of SDKs which have been custom designed, custom built for different use cases, and available out there. And there's nothing really there, proactively, preventing or blocking attacks there. I would say we are really actively investigating in that area. There are a lot of things you can do, like by looking at the application behavior, how applications behave, what is good, what is bad, learning that, and at the same time taking actions based on what exploit behavior looks like. You can do a lot of very advanced algorithms and analysis to prevent application-based attacks, but it's still very early. AI is just touching this various spaces in cybersecurity right now. For application security, it's really early days, and there are very few early players which I have come across right now in the market. Yeah. All right, I think.
Unfortunately, I think we'll cut it off right now. You can always catch him later. He's here. So with that, I think let's go to first panel.
Okay, thank you.